What is data science? Data science is the process of using scientific methods, techniques, and tools to extract insights and knowledge from data. It involves collecting, cleaning, analyzing, and interpreting large sets of data to make informed decisions and predictions. In layman's terms, data science is like detective work, where you use data as clues to uncover patterns and insights that can help businesses, organizations, and individuals make better decisions. It's a combination of math, statistics, computer science, and domain expertise that helps turn data into actionable information. An example of data science in action would be a company analyzing customer purchase data to determine what products are most popular and at what times of the year, and then using this information to make decisions about inventory and pricing. It's a field that is becoming increasingly important in today's digital world, as we collect and generate more data than ever before, and businesses have to be able to make sense of all that information. Data science is important in today's world because it helps organizations and individuals make better decisions by turning data into actionable information. With the large amount of data being generated and collected, it's becoming increasingly necessary to be able to extract insights and knowledge from that data. For example, in business, data science can be used to analyze customer behavior and predict future buying patterns, which can help companies make informed decisions about inventory and pricing. In healthcare, data science can be used to analyze medical data and find new treatments for diseases. In sports, data science can be used to analyze player performance and develop strategies for winning games. Data science also plays a key role in the field of artificial intelligence, AI, and machine learning, which are becoming more prevalent in a wide range of industries, including finance, retail, healthcare, and transportation. In simple terms, data science helps us make sense of the enormous amount of data that is being generated every day and make better decisions based on that data. This can lead to more efficient operations, improved products and services, and new discoveries that can benefit society as a whole. In this section of the series, we will be covering the fundamental concepts and techniques that form the foundation of data science. We will begin by introducing the different types of data and data structures, and then move on to cover essential techniques for data visualization, cleaning, and preprocessing. Finally, we will delve into the basics of statistics, which are crucial for understanding and analyzing data. The field of data science is constantly evolving, and it's important to have a solid understanding of these fundamentals in order to be able to effectively work with data. We will be providing examples and case studies throughout the section to help you better understand how these concepts are applied in real-world scenarios. By the end of this section, you will have a good understanding of the different types of data, how to prepare and clean data for analysis, and the basic statistical concepts that underlie data analysis. With this foundation in place, you will be well prepared to move on to more advanced topics in data science. Data comes in many different forms, and it's important to understand the different types of data and how they are structured in order to effectively work with it. In data science, there are two main types of data: structured and unstructured. Structured data refers to data that is organized in a specific format, such as a table with rows and columns. It is easy to process and analyze as it follows a specific schema. Examples of structured data include relational databases, such as MySQL or PostgreSQL, spreadsheets, such as Microsoft Excel, and CSV files. Unstructured data, on the other hand, does not have a specific format and can come in many different forms, such as text, images, or videos. It is not easy to process and analyze as it does not follow any specific schema. Examples of unstructured data include social media posts, emails, and PDF documents. In addition to these two main types of data, there is also semi-structured data, which has some structure but not as much as structured data. Examples of semi-structured data include JSON files, XML files, and log files. Once you have a good understanding of the different types of data, it's important to understand how that data is structured. Common data structures include tables, also known as data frames or matrices, lists, arrays, trees, and graphs. Each data structure has its own strengths and weaknesses and is better suited for different types of data and tasks. Understanding which data structure is appropriate for a given situation is an important aspect of working with data. Once you understand the different types of data and data structures, you can then move on to the next step, which is data visualization. This step is crucial as it ensures that the data is in a format that can be easily analyzed and that any inconsistencies or errors are removed. Data visualization is the process of creating graphical representations of data in order to make it easier to understand and interpret. It is an important aspect of data science as it allows for the discovery of patterns, trends, and insights that may not be immediately obvious from looking at raw data. There are many different types of data visualization techniques and tools, each with their own strengths and weaknesses. One of the most basic and widely used forms of data visualization is a simple chart or graph. These include line charts, used to display continuous data over time. Bar charts, used to compare different categories of data. Pie charts, used to show the proportion of different categories of data. Scatter plots, used to show the relationship between two or more variables. Another form of data visualization is heat maps, which are used to show the density of data points in a particular area. These can be used to identify clusters or outliers in the data. A more advanced form of data visualization is interactive visualization, which allows users to interact with the data and explore it in more detail. These can include interactive maps, dashboards, and virtual reality visualization. Data visualization also plays a vital role in data exploration and analysis. It helps to identify patterns and outliers that might not be obvious from looking at raw data. It can also be used to communicate findings and insights to non-technical stakeholders. Choosing the right visualization technique depends on the type of data you are working with, the question you are trying to answer, and the audience you are trying to communicate with. Overall, data visualization is a powerful tool that allows us to make sense of large and complex datasets, and it is an important aspect of data science that helps to uncover insights and patterns that might otherwise go unnoticed. Data cleaning and preprocessing is the process of preparing data for analysis by removing errors, inconsistencies, and irrelevant information. It is an essential step in data science as it ensures that the data is in a format that can be easily analyzed, and it can also increase the accuracy and reliability of the results. Data cleaning can involve a wide range of tasks, such as removing duplicates, handling missing values, formatting data into a consistent format, removing outliers, correcting errors, and removing irrelevant information. For example, in a dataset containing customer information, data cleaning might involve removing duplicate records, correcting errors in customer addresses, and removing any irrelevant columns such as customer ID. Data preprocessing is the step that comes after data cleaning, and it involves transforming the data into a format that is suitable for analysis. This can include tasks such as normalizing data, one-hot encoding categorical variables, scaling numerical variables, aggregating data, and reshaping data. For example, in a dataset containing customer information, data preprocessing might involve one-hot encoding the categorical variable, gender, and scaling the numerical variable, age. Data cleaning and preprocessing are important because they help to ensure that the data is accurate and reliable. They also help to reduce the risk of errors in analysis and improve the performance of machine learning models. Additionally, it helps to make the data more consistent and understandable, which makes it easier to explore and analyze. It's also important to note that data cleaning and preprocessing are iterative processes, meaning that they may need to be repeated multiple times until the data is in the desired format. Overall, data cleaning and preprocessing are essential steps in data science that help to ensure that the data is accurate, reliable, and in a format that can be easily analyzed. They are crucial for producing accurate and meaningful results from data analysis.